Welcome back to Manish Kumar channel. So today we are talking about functions of complex variable. So let capital S be a set of complex numbers. A function f defined on S is a rule that assigns a complex number w to each z in S. Right? That means fz equal to w. Right? The set S is called the domain of F. Domain of F means domain of the definition, right? And you know domain here we are referring as open connected set, right? Open connected set is known as domain, right? Okay. So it is important to note that the function is well defined only when both its domain and its defining rule are specified. If the domain is not explicitly mentioned, we assume the largest possible set where function is meaningful. Okay. So if I'm talking about like uh, your z plane, so your x and y, this is iota I-axis, and in w plane will be u, and this is v. So imaginary axis. So this is w plane. Okay. So any function f, let's say if I'm going to make uh, this circle, so I'm saying that modulus z is less than 1, right? So this is an open as well as connected domain, okay, because boundary is not included. And then we can define any function f. So if we say fz is equal to, let's say, z, right? So what will happen? It will give the same circle, right? So this is your W domain. It depends upon your functions, whether function give single valued or multiple valued. So if you have any power of z, z cube, and so on, then you will get single valued function, single valued, right? Single valued function. Okay. So now let us see one example. So this function is clearly a polynomial type. So this is single valued, right? So we know z can be written as x plus iy, and then we can plug in the function value and then getting the square. So you can see it here, fz can be written in this form where u and v. So you can write fz is equal to u plus iv, which is in w plane as written as w, right? So you can separate real and imaginary part. Also, you can write in the polar form as well, because we know z can be written as r e power I theta. After plugging this value, we are going to get, real part and imaginary part, right, in terms of polar form. Uh, Another example is fc is given by this, because this gives a real valued function. If you see 5 times of modulus of z square, and modulus of z square is x square plus y square, 5 times multiplication is happen in each term, and no imaginary part, so I can write I times of 0. So u is 5x square plus 5y square, and v is 0, right? And if n is a non-negative integer and a0, a1, and so on, an are complex constants with an not equal to 0, then the function Pz can be written as a naught plus a1z plus a2z square and so on an z power n, such that an is non-zero. So this is called a polynomial of degree n. This is called the degree, right? And if you see this function is entire function because it is defined in the entire complex plane, right? So this function is also known as entire function. Okay. So if you say Pz, uh, you can also say another example of entire function e power z, right? It is also defined for entire complex plane. So these all are the entire function which is defined for every complex number c. So we call it as entire function. Okay. Similarly, a function of the form Pz by Qz, where Qz and Pz are polynomial and Qz non-zero, right? Because denominator should not be zero, this denominator. Okay. And this polynomial is known as, the rational functions, right? Rational functions. Okay. And rational function and polynomial are very important in complex analysis, right? A more general concept of functions allows a single point z in the domain to correspond a multiple values. These multiple valued functions naturally arise in the study of complex functions, right? As like real analysis, right? So when dealing such functions, it is common to systematically select one value at each point, thereby constructing a single valued functions from the original multi-valued function. So if you see example, well-known multiple valued function is the complex uh, algorithm function, which is defined as logarithmic of z equal to ln of modulus of z plus I argument of z. So you can also write it as ln of r plus I theta, right? And in more general case, you can write it as log of z equal to ln of z plus I theta plus 2 k pi, where k belongs to z. So see here, because of the argument is not unique, right? And that can take values by differing multiple of 2 pi, right? Therefore, this provide a multiple valued function. So to define a single valued function, right, we need single valued branch of logarithmic z. A branch cut is introduced, restricting the argument z to principal value, right? So principal value will help to give the unique, value, okay? Because we know principal value will give always unique value, which is commonly chosen as minus pi and pi in between argument of z, right? So this is a multiple valued function. Okay. Another example, you can see fz is equal to z power 1 by 3, right? So this problem has, a multiple valued, okay? And it Riemann surface has three sheets, right? Similarly, if you see this logarithmic has infinite sheet, infinite sheets. You got it? So, for instance, if we know the cube root of unity, right? If you know in complex plane, So, this cube root of unity will be. So what had happened here is this will give one sheet, this will give another sheet, and this will give another sheet. So there are three sheets we are going to get for cube root of unity. Okay. So thank you very much. Thanks a lot.